Good afternoon. Today we will discuss about this block 2 of Unit 8, which generally speaks about the project operation planning and control. If you recall, in my last 3 lectures, we have discussed mass production, batch production, and job shop production. Today we'll take up another type of operations that is called project. And in project operations, how it is planned and how it is controlled, today we'll discuss. Now, the first step in management of the project is to understand the interrelationship between the various activities which constitute the project. The activities may be interlinked with each other in various ways. For example, the activities preparations of tea and preparation of snacks may be interlinked with each other by the type of resources required in case of gas stove. On the other hand, the activity serving tea cannot be started unless and until the activity preparation of tea is completed. Unlike the other examples, this dependence cannot be freed for providing additional resources. So, in this introduction, I want to highlight that we'll discuss in subsequent slides what is project, but in our real life, we find certain things, certain activities which are interlinked, and the dependence of these activities constitute the project. Suppose I gave an example here, the activities of preparation tea and preparation of snack. Suppose the gas stove is one and we are preparing tea. Unless the tea is completed, we cannot prepare the snacks. Cannot be started unless and until the activity preparation is completed. Unlike other examples, the dependence cannot be free by providing additional resources. List of activities for the project: arranging a tea party. Suppose on a birthday, a person is invited his friends, relatives, and he has arranged a tea party. Now, in arranging a tea party, if you call this a project, we can find there are certain interlinked activities. We start with the procure material, B, prepare snacks. So first procure the material, then we prepare snacks, arrange for the cutlery, then D, prepare the tea, set the table with snacks and cutlery, serve tea and clean cutlery. So we shall make the following observation. Each activity needs physical time for its completion. Certain activities are interrelated in the sense tea cannot be actually served until preparation is completed. Each activity will require one or more resources such as manpower, equipment, raw material, etc. And project will be completed if all the activities are completed. So, when I arrange a tea party and I have given you, say, A, B, C, D, E, F, G activities, when all the activities from A to G are completed, we can say that the project is completed. And procure material and prepare snacks. They are interdependent. I cannot prepare snacks unless I have materials. So first I have to procure materials. That is the sugar or flour, whatever is required for the preparing snacks, and arrange for cutlery. Then prepare tea and serve tea. D and F are, say, interdependent. I cannot serve tea unless tea is prepared. And clean cutlery will arise only when the people or the invitees have taken the tea and snacks. So unless the party is over, I cannot clean cutlery. So From this example, it's very clear that each activity, if I take procure materials is an activity, then it will take some physical time for its completion. One has to go to the market, one has to spend some time in going and coming and purchasing the required materials. So it will take some time. And second thing is most visible is certain activities are interrelated in the sense some activities cannot be started unless some activities is completed. Each activity will require one or more resources, such as, for example, to prepare snacks, we require a cook or a chef, or for serving the foods, we require a, say, waiter, raw materials, equipments, we require a gas stove and other cutleries. A project will be completed only when if all the activities are completed. Thus, in any feasible time schedule, activity serving tea has to be scheduled only after the completion of the activity preparation of tea. This kind of interdependence will be referred to as precedence requirement. An activity B is said to succeed activity A if in any feasible time schedule B has to be scheduled only after completion of A. A is said to be predecessor of B. Project network are used to visually depict through arrow diagrams. So, in this activity, we find certain activities are predecessor, certain activity are successor. Now, here, this kind of interdependence is referred to precedence requirement. Suppose I have given an example here, B is said to succeed activity A. That means B is said to succeed activity A. That means B can only start, B has to be scheduled only after the completion of A. So A is said to be predecessor of B and B is called successor of A. So in this Tea Party example, we find certain activities are successor, certain activities. Now, procure materials and prepare tea. A and B, as I give you, A is predecessor, B is successor because I can schedule the preparation of snacks when the procurement of material is completed. Now, we discuss what is project. What is mean by project? Now, before we formally define project, it will be a good idea if you describe in your own words your impression of the word project. Now, consider the following two situations: preparing tea, arranging for a tea party. If you look at the above two situations, then arranging for tea party will require preparing tea, one of the tasks, as one of the tasks. In fact, arranging for tea party will require organization of other tasks such as issuing invitations, procurement of snacks, procurement of cutlery, table arrangement, serving tea, etc. You will agree that arranging for tea party is much more complex task consisting of large number of simpler tasks or activity such as preparing tea. We will call arranging for tea party as a project while we refer to individual tasks as preparing tea as activity and the list of all these activity for this project. Yes. Now, here, before we formally define, we have a good, you can understand the meaning of project in your own words. Now, preparation of tea and arranging for tea party. What is the difference between the two? Preparing of tea is an activity and arranging for a tea is called an project. So, preparing of tea is activity because it takes some time, but arranging of a tea party is consist of various activities. When all the activities are completed, we call the project is completed. Now, I have listed out what are the things we require for, what are the activities generally required for arranging a tea party. Now, first activity we need is require such as issuing invitations. Who are your invite people who are supposed to come and attend your tea party? To them, we should send invitations. Procurement of snacks. Other, you can prepare the procurement or you can purchase. Procurement of cutlery, plates, and other things. Then you have to arrange the table where it will be served. Then serving tea. That arranging tea party is more complex. If you compare preparing tea and arranging a tea party, the second one, the latter one, arranging for a tea party is more complex than preparing a tea, because preparing a tea is an individual activities, whereas arranging for a tea party is consists of list of activities for this project. So from this above example, we can say that project is nothing but is a combination of activities, and projects are taken once in a lifetime. Generally, it's not a repetitive activities. Suppose construction of bridge, construction of highway, isn't it? So network, say communication network, all these are in projects in nature. So preparing tea, we may prepare tea for ourselves every day at our home, but we don't arrange tea party. We occasionally arrange tea party. So it's not repeated every day. The projects are not repeated every day. So project is not a repetitive activities. Project is sometimes some projects are done once in a lifetime. So from the list of precedence activity, project network is done using arrows. Each activity is presented as an arrow, which is a line with a small circle at each end called node. So this figure is there. You can see from the list of precedence activity, project network is done using arrow. How do you? So in a network diagram or in a precedence activity, we show the net activity by arrow mark. And when the activity is represented by arrow, which is a line with a small circle at the end, at each end called the node. Now, when activity A precedes another activity B, then the end node or circle of activity A is merged with the start node circle of activity B. The following diagram represent the precedence requirement of now what he says here, if activity A precedes another activity B, that means A is the predecessor of activity B. That means A must be completed when B can start. So a precedence, when you draw a network diagram, the end node of circle of activity A is merged with the start node of circle of activity B. So A is called a predecessor activity, B is called a successor activity. So that means when such a condition is there, then the end node of activity A is merged with the start node of circle activity B. A network diagram. What is a network diagram? A network diagram is a graphic representation of projects, operations, and a composed of activities and events that must be completed to reach the end objectives of a project, showing the planning and sequencing of time accomplishment, their dependence and interrelationship. So basically, when you talk about a network diagram, it is a graphic, it's a diagram, it's a graphic representation of project operation. So when a large project is there, lot of activities are there, lot of events are there, and project network is drawn first. Now, project network is a technique by which we represent the various activities and events that are involved in a project, composed of the activities and events that must be completed to reach the end objective of a project. Now, network diagram is very handy. What it shows? The sequence of time accomplishment, the sequence. So it shows which activity is to be done first, which is need to be followed, and their dependence. That means who is successor, who is the predecessor, who are concurrent, we'll discuss later on, and what is their relationship, interrelationship. So a network diagram is a very handy technique for all the project managers or for all operations managers, because it gives a fair idea about the interrelations and interdependence of the various activities and their sequence of the various activities. Now, what are the components of network? The basic components of network are: first is an activity. Now, an activity is a task or time of work to be done that consume time, effort, money, or other resources. An activity is represented by an arrow with the head indicating the sequence in which the events are to occur. Very important. Now, a network diagram has many components. One of the important component is activity. Now, what is activity? Activity is a task. Suppose I am going from my home to office is an activity. So while going, we consider it a task or the item of the work to be done. Now, while going from home to office, it consumes time. It may take 10 minutes, 20 minutes, 30 minutes, depending on the situations, traffic situations. I have to make certain efforts. I have to say book a cab or my own two-wheeler or four-wheeler. That money, why I have to spend the fare on my cab or public transport, or I have to spend on my petrol or other resources. So activity consumes time, activity consumes effort, activity consumes money, and activity consumes resources. And how is an activity is represented? An activity is represented by an arrow and with his head indicating the sequence. Then the head generally represents in which order the sequence or the events are to occur. So the first and foremost important components of a network diagram is activity, and activity is a time consuming entity, effort consuming entity, money consuming entity, as well as it is an say resource, it also consumes resource. Now, an event represents the start or beginning, completion or end of some activity, and such it consumes no time. It has no time duration and does not consume any resources. It is also known as node. In event is generally represented in the network by circle. So if you compare event with activity, activity consumes time and event doesn't consume any time. Suppose I give you an example. Now, we are going from home to office. So there are two start points. This activity has two start points. That is starting from your home and reaching at your office. So these two are called events. So each activity has a starting event as an end event. An event represents the start or beginning of some activity. So how the event is represented? The event is represented in a diagram by a node or by a circle. Is represented by a circle. So when a activity starts, there is a circle, and where the activity ends, there is also a circle. It is known as node. An event is generally represented in the network diagram by a circle. So event does not consume any time. It refers to a particular point of time. So reaching the office is called an event. or starting from your home is an event. So starting from your home and reaching your office is called an activity. So this too has a beginning point and end point. Now, what are the types of activities generally we find? Predecessor activity, an activity which must be completed before one or more activities start, is known as predecessor activity. I have already discussed, but again I will highlight this. In a network diagram, there are certain activities are called predecessor activity. Suppose you get up in the morning, you want to have breakfast. So before breakfast, you have to complete certain other activities. So cleaning your teeth, brushing your teeth, or taking a bath. So predecessor activity means an activity which must be completed. The other example I told you, the first slide, if I go here, yes, preparation of tea and serving of tea. Preparation of tea and serving of tea. So preparation of tea is called predecessor activity because preparation of tea must be completed before we serve the tea. We cannot serve a tea unless the preparation of tea is completed. An activity which started immediately after one or more activities are completed is known as successor activity. The same example we can take, say serving tea and preparation of tea. Serving tea is referred to as the successor of preparation of tea. An activity which started immediately, which is the serving of tea has started immediately after the preparation of. Then certain activities are called dummy. What is dummy? They look like activity, but they are not actually activity. Why? That an activity which does not consume either any resource or time is known as dummy activity. A dummy activity is depicted by a dotted line in the network diagram. So how it is in predecessor activities and successor activity are shown by normal lines without any dots, but dummy activity is shown by dotted lines. Now, what is the role of dummy activity in a network diagram? The role of the dummy activity is to maintain or to show the logical sequence of the various activities. Sometimes to maintain the logical sequence of the predecessor and successor activity, we use dummy activity. Now, various known techniques are available for network planning and actions. But here we will only concentrate on CPM and POT. These two methods provide a methodology for planning, scheduling, and controlling of project implementations. So, when you make a network planning or network scheduling, there are a lot of mathematical techniques, operation research techniques are available, and most important of them are CPM and POT. CPM stands for critical path method and POT stands for project evaluation review technique. Now, these two techniques are increasingly or predominantly used in the project planning and scheduling activities. Yes. Prior to the development of POT and CPM, another popular technique for project scheduling was the bar or Gantt chart. These charts show a graphic representation of work on a time scale. The primary limitations of this technique is the inability to show the interrelationship or interdependency among the many activities which control the progress of the project. Also, although it is possible to redraw the chart to show the interrelationship, but confusion arises the size of the project increases. To overcome such limitations, partnership was CPM was proposed in the late 1950s. So prior to 1950s, where part and CPMs were not used, then the project manager took the help of Gantt chart to project planning and control. Now, the Gantt chart is a graphical, say, is a horizontal bar chart where on the bar it is shown on the graph, one axis represents the, say, different activities, and it shows what is the plan and what are the actual. Now, what while starting or while planning a project, we have planned some days. Suppose there is a project A, we have planned to complete in 10 days, but after 10 days it is shown that 80% is completed. So what is the plan and what is the actual? The primary limitation of this project is their interrelationship, because it's unable to show the interrelationship or interdependency among many activities. Though it is possible to redraw the chart to show the interrelation, but this Gantt chart is not very useful, or confusion arises when the project size increases. When project size is very large, project size is very complex, when many activities are involved, then Gantt chart may not be a, say, suitable technique for project planning and control. Therefore, to overcome this problem, POT and CPM was proposed in late 1950s. So, logical sequence in the network diagram, all project consists of certain activity that can begin only after certain others are completed. In fact, the entire project may be considered a series of activity which may begin only after another activities or activities are completed. In a network schedule, these types of relationships are called constraints or represented by inequalities. In logical sequence, the following types of errors are most common while drawing a network diagram: looping and dangling. No activity should end without being joined to the end event. If it is not so, a dummy activity is introduced to maintain the continuity of the system. Such an event other than the end project as a whole are called dangling events. So, in a network diagram, we have to maintain the logical sequence. All the project consists of certain activity that can begin only after certain activities are completed. So, in a network diagram, we will find certain activities are successor, certain activities are predecessor. In that sense, we mean that only some activity can be started after some activities are completed. If you talk about project, it can be considered a series of activities which may begin only after another activities or activities are completed. But in a network schedule, this type of relationship is called constraint. Why it is called constraint? Because B cannot start unless A is completed. So in mathematics, in a network diagram, some activities may also be called a concurrent activity. That means they can be carried out simultaneously at the same time. So in a network diagram, following two types of errors most common while drawing a network diagram. One is looping. What is looping? Looping is events other than the end of the project as a whole are called dangling events. No activity should end without being joined to the end event. If it is not so, a dummy activity is introduced in order to maintain the continuity of the system. Yes. So when you draw a network diagram, no activity should end without being joined to the end event. So if it is not joined, it is called dangling. And to overcome this problem, we have to use the help of a dummy activity. Rules of network diagram. Three rules are available for constructing. Each activity is represented by one and only one arrow. Activity must be identified by two distinct end nodes. No two more activities have the same tail. To maintain the correct precedence relationship, the following sequence must be used. Now, what is the rules for network diagram? Each activity is represented by one and only one arrow. Suppose there are four activities, then we have to use four arrows. We cannot represent all the four activities by one arrow. And each activity must be identified two distinct end nodes. That means one is starting node and one is completion node. One is starting circle, another is completion circle. No two or more activities can have the same tail. Yes. So two or more activities can have the same, no two or more activities can have the same tail. To maintain the correct precedence relationship, we have certain questions. Now, there is an important technique. This technique is called Fulkerson rule. How to number the Fulkerson rule, numbering the event, Fulkerson rule. After the network diagram is done in a logical sequence, every event is assigned a number. The number sequence must be such as to reflect the flow of the network. In the event numbering, the following rules should be observed, which is also known as Fulkerson's rule. The event number should be unique. Event numbering should be carried out on a sequential basis from left to right. The initial event should, which has all outgoing arrows with no incoming arrows, is numbered 0 or 1. The head of an arrow should always bear a number higher than the one assigned at the tail of the arrow. Gaps should be left in the sequence of the event numbering to accommodate subsequent inclusion activity if necessary. Then Fulkerson rules says about how to number the events. First, he says that events must be unique in nature. What do you mean by unique? If there are four events, then four events should get different numbers. The numbers should not be identical or same for all the four events. Now, if there are four numbers, then there are four events, 1, 2, 3, 4. The event which is carried out first should be numbered a lesser number, 1. Second one, 2, 3, 4. We go from left to right. That means the event should be carried out in a sequential basis from the left to the right. From the left to the right. The initial event which all outgoing arrows. So the initial event where there is only outgoing, there is no incoming arrows. It should either be numbered 0 or 1. And the head of the arrow should always bear a number higher than the assigned at the tail of the arrow. That means the head of an arrow, head event should be a higher number than the tail event of an activity. And there should be gap left in the sequences of event numbering to accommodate the subsequent inclusion. Now, objectives of network diagram. As you know, the project involves high cost. and project involves crores of rupees is a complex things. Lot of money are spent. If the project is delayed, then there will be explanation of cost. There is increase in cost. So the primary objective of network diagram to minimize the total project cost. Then second is minimization of total duration. Yes. Suppose the project is need to be completed in a particular year, say 1 year or 2 years. If it exceeds the planned duration, so there may be some penalties. To overcome these penalties, we use the network diagram. So network diagram is very useful for planning the time or controlling the trade-off between time and cost concept. What is trade-off? Trade-off is a very important concept. If you finish in less time, the cost of the project will increase because we require additional resources for the project for completion. So we should maintain a balance that is called trade-off, time and cost of the project. Minimization of idle resources. That means resources are very important. Resources are paid. And if the resources do not do any work and they do not do any work and they sit idle, then they becomes unproductive. Then there will be a cost to the project and to minimize the production delays. So when you talk about network diagram is essentially a diagram for project planning and control. So first thing it does is minimization of total project cost, minimization of the total project durations, and to maintain the balance between time and cost of a project, to minimize the idle resources, and to minimize the production delays. Now, CPM and POT are network-based models designed to assist in the planning, scheduling, and control of projects. A project is defined as a collection of interrelated activity, with each activity consuming time and resources, as I already told you. So, CPM and POT are network-based models designed to assist the planning and scheduling and control of project. Planning means when it start, what are the resources, what are the manpower, all planning, scheduling, when it will start, when it should finish. Now control, it should finish in particular time with particular cost. If the cost is more or time is more, then we have to take certain controlling measures. And projects is nothing but is a collection of interrelated activities, with each activity consuming time and resources. So again, I am saying that activity consumes time as well as resources. Now, talking about the objectives of CPM and POT is to provide analytical means for scheduling the activities. That means CPM and POT are very useful analytical techniques, where we can schedule the activity. That means when the activity can start, when it can be. And there are certain steps. I have given 3 steps. We define the activities of the job. First, we have to define what are the activities of the project. As I told you in the beginning of my lecture, arranging a tea party, we first define what are the activities needed for arranging a tea party. Then there precedence relationship. What is precedence relationship? We should find out who are the predecessor activity and who are the successor activities, and their time requirement, and what time these activities can be completed. The precedence relationship among the activities are represented by a network. Once you write in a table the precedence relationship, then this is represented by a network diagram. specific computations to develop the time schedule for the project. During the actual project's execution of the project, things may not proceed as planned and some of the activity may be expedited or delayed. When this happens, the schedule must be revised to reflect the realities on the ground. This is the reason for including feedback loop between the time, schedule, phase and network phase. So these are the important CPM objectives. POT and CPM provide analytical means, and first we start with defining the activities, their relationship. The precedence relationship among activities are represented by a network diagram. Then we do some mathematical computations to find out the time schedules for the project. During the actual execution of the project, things may not proceed. Suppose I have planned to do something, but there is a strike, there is a lockout, resources may not reach me. So if things do not go as per the plans, we have to take some measures. We have to take some measures so that it can come on track. So we should, when the project is delayed or is expedited, we can revise to reflect the realities on the ground. This is the reason for including feedback loop between the time schedule phase and network phase. Now, two important techniques which were developed independently differ in that CPM is an assumed deterministic activity duration, POT assumes probabilistic duration. It is commonly used for those projects which are repetitive in nature, where one has prior experience of handling similar project. It is a deterministic model and place emphasis on time and cost for activities of a project. Very important concepts are here. Now, CPM is used for projects which are repetitive in nature. That means those projects are repeated. Suppose an MBA students, all MBA students do their summer projects during summer period. So we know what is the experience of how much time, where they should go. So we can know this, or arranging a tea party once in a month we arrange it. But what is called project evaluation review technique, it is generally used for those projects which require to complete various activities are known as priority. It is probabilistic model. It is primarily concerned for evaluation of time. It is event oriented. CPM is activity oriented. POT is event oriented. And CPM, we know the predetermined time. We know the time and the cost. It emphasizes on time and cost for activities of project. So the difference between POT and CPM, the difference between POT and CPM arose primarily because of the original job for which particular techniques were developed. Initially, POT technique was applied to research and development projects, while CPM was used for the construction projects. Both of them in common in notion of a critical path and are based on network plan. They determine the most critical activities to be controlled so as to meet the completion dates. So when you're talking about the difference between POT and CPM, the difference between them arose because for the reason for which these techniques were developed. If you go to the history of POT and CPM, we find POT technique was applied for R&D related projects, while CPM was used for construction projects. So in R&D, we are not sure. It's all probabilistic. But construction projects, we know that similar projects are taken. Both of them, we have prior experience of but in research and development, when we newly develop and research a particular thing, we are not sure what will be the both of them in common the notion of critical path and are based on network plan. But the similarity between them is that both use the network diagram and both determine the critical path. What is critical path? Critical path consists of those activities. These are critical to the project. If these projects are delayed, then the whole project will be delayed. So extra cares need to be taken to control the critical activities. Now, event part and CPM, if you take the difference, it is event oriented. So part gives more emphasis on event, whereas CPM gives more emphasis on activity because, as I already told you, part CPM emphasizes on time. So activity consumes time. It is probabilistic in nature. Why? We don't know what is the time of completion of a project. So in part we use three types of time that we will discuss. That is the optimistic time, pessimistic time, or normal time. From there we get the average time. Whereas in CPM we use a single time because we know it is deterministic in nature. It is concerned with time and cost. What is related to with time as well as cost, where CPM is concerned with only time. What is used for new projects? That means the projects which are not taken earlier, in those projects we use spot, but CPM is used in those projects which have already undertaken, which are already, so in repetitive project we use CPM. Now we will discuss critical path method. The end result of CPM is construction of a time schedule of the project. To achieve this objective conveniently, we carry out special computation that produce the following information. Total duration needed to complete the project, classification of the project as critical and non-critical. An activity is said to be critical if there is no leeway in determining starts and finish times. And non-critical activity allows some scheduling slack. So the start time of the activity can be advanced or delayed within limits without affecting the completion date of an entire project. So here two things are very important. One is your CPM. CPM is the construction of time schedule for the project. So what you calculate here? We calculate the total duration needed to complete the project. And CPM allows us to classify the activity into critical and non-critical activities. What is critical activities? Critical activities are so which is there is no leeway, means there is no idle time or slack time available to a critical activity. That means critical activity start cannot be delayed. Yes, if it is delayed, then it will impact the whole project. The whole project duration will also be affected. So therefore, extra care generally taken to control the critical activity. On the other hand, a non-critical activity allows some time scheduling slack. That means it allows certain slack. It allows certain time which we can delay the project within a limit, without affecting the completion date of the entire project. So if you compare critical and non-critical activity, critical activity should be taken into consideration. To carry out necessary computation, we define an event at a point in time at which activities are terminated and others are started. In terms of the network, an event corresponds to a node. So what is To carry out the necessary computation, we define event as a point in time at which activities are terminated. One activity is end and other activity is started. And in general, the events correspond to a node or a circle. So define earliest occurrence time of event I. So what is uh, earliest occurrence time? Earliest occurrence time, the earliest time in which an activity can occur or can start. Latest occurrence time of event J. That means the latest time by which an activity can be completed. Duration of the activity. This definition of the earliest and latest occurrence of are specified relative to the start and completion dates of the entire project. So EI stands for the earliest occurrence of the event I, and LJ stands for the latest occurrence of the event J, and Dij is duration of the activity Ij, activity I and J. The critical path calculation involves two phases. One is forward pass, determine the earliest occurrence times of the events, and the backward pass calculate the latest occurrence time. Now, in a forward pass method, we start from the left to the right. We start from the first activity. So initial state, we generally starts with the first activity, or those activities we do not have any predecessor activity, which have only outgoing arrows. There is no incoming arrows. Now, the rule says for forward pass method, rule says that if an activity doesn't have any predecessor activity, then the earlier start time of this project is set to be 0. The project time can be started immediately. So for this earliest occurrence of the events, then we calculate from here, from the EST, we calculate from the earliest start time, we find the EFT, earliest finish time. Generally, the EFT is calculated as EST plus the work duration. Now, first rule says in the forward pass method, an activity which do not have any predecessor activity, the earliest start time is 0, then earliest finish time is earliest start time plus the work durations. Then we have to look after the activities which have one predecessor activity. Suppose A and B is predecessor, A is the predecessor of B. That means B can be started only when A is completed. Suppose the work duration of A is 3 and work duration of work B is 4. How to calculate EST and EFT? Suppose A is the starting activity, it has no predecessor activity. We can immediately say that the EST of A is equal to 0 and EFT of A is equal to 0 plus 3 is equal to 3. Now, after that we look after which activity has only one predecessor activity. Now, B has only one predecessor activity. So, here the EST of B happens to be the EFT of A. Earliest finish time of A becomes the EST of B, that is 3, and the work duration of A is equal to 4. So it's called 7. Then there may be some activities which have more than one predecessor activities. In that case, what happens? Suppose C has two predecessor activities, A and B. So here in that case, we have to find out whether A is the minimum EFT or B has the minimum EFT. We have to take the minimum of that. We have to take the maximum of that. Whichever is maximum, we take that activity. maximum. This is written maximum. We have to take the maximum. So if A is the maximum, then we take the CS. In backward pass method, initially step method, the to indicate the earliest and the latest occurrence of the last node of the project are the same. General steps, we start from in the backward pass method, we start from the last activity to the first activity. Yes, there are three conditions that start the earliest and latest occurrence times in the node. So another important concept is float. What is float? Float refers to idleness. In case of non-critical activities, certain amount of spare time is available, and this spare time is called float. There are three types of float: total float, free float, and independent float. So what is total float? Total float is defined as the amount of time by which the completion of an activity could be delayed beyond the earliest expected completion time without affecting the overall project duration time. So it is Lj minus Ei is equal to minus the Dij. Free float. In calculating the free float, only a particular activity has been considered with respect to tail and head event times. But it may be necessary to find out how much an activity can float without affecting the flexibility of the movement of the immediate succeeding activities. The free float is that part of the total float which can be used without affecting the float of the succeeding activities. So the last line is very important. The free float is the part of the total float which doesn't affect the float of the succeeding activities. Independent float. This independent float time of an activity is the amount of float time which can be used without affecting either the predecessor or the successor activities. And we can calculate accordingly. Then POT is another method. As I told you, POT model is a probabilistic model. In the CPM model, scheduling times of various activities, the critical path and project length were all determined on the basis of activity times which are assumed to be known as constant. So in CPM method, we know that the times and of different activities are assumed to be known and constant. We know it from beginning. But according to POT originators, any activity in a network is unlikely to be completed on time. Now, I give you an example. When you go to in a city, when you go from one place to another, sometimes you reach earlier, sometimes you are much delayed, or sometimes it is on normal time. Suppose a train is moving in a particular direction, in a particular station. Sometimes the trains are on time, sometimes it is late, sometimes it is over, say before time. So we cannot say that a work or activity can be completed on time always. There may be some situations where it may be earlier, so it's called a optimistic time. Sometimes it may be delayed. We can say it's a pessimistic time. Sometimes it is called normal time. So on the basis of that, we calculate an average time. While at other times, unexpected snags may occur, causing unplanned delays. So there are three types of optimistic time, most likely time, and pessimistic time. Then we calculate the average time by using the formula, and we also calculate the standard deviation using the formula. Then draw the project network, then compute the expected duration of each activity, compute the expected variance, compute the earliest and start finish, latest finish, then determine the critical path and identify the critical activities. And compute the expected variance of the project length, which is sum of the variance of all critical activities. And lastly, compute the expected standard deviation of the project length and calculation. Thank you very much. This brings to the close of this session, that is the block 2 of your MMPC 009.